Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper trending on X, published on July 30th, 2025. So, just yesterday. This paper argues that the best way to improve AI agents isn't just to make them more autonomous, but to build them for human collaboration from the ground up. The paper is titled Magentic-UI Towards Human-in-the-Loop Agentic Systems, and the results really back this up. For instance, the authors show that with even lightweight human feedback, task accuracy on the GAIA benchmark improved by 71%. They achieve this with an open-source framework designed to explore this, with built-in safety guards and new ways for people and AIs to work together on complex tasks. And it's already getting some buzz online. One of the authors, Hussein Mozanar, shared the work on X, highlighting how their report details key interaction patterns like co-planning and co-tasking. He explains these patterns are designed to enable effective interaction at a low cost for users. The official AutoGen account also pointed to the technical details, and the author encourages the community to try out the open source code, inviting everyone to experiment with these new human-agent interfaces. Alright, and this first figure gives us a fantastic visual overview of the Magentic-UI system itself. It lays out the 6 key ways a person can collaborate with the agent. We see things like co-planning, where you can edit the AI's plan before it starts, and action approval, which is a safety feature that asks for your permission before taking critical steps. It really visualizes this idea of a human-in-the-loop agentic system, which just means designing AI agents to work as a team with a person rather than completely on their own. Building on that idea, this next figure shows us what the Magentic-UI interface actually looks like in action. It's all powered by what's called a multi-agent architecture, which means it's not just one AI, but a team of specialized agents coordinated by a leader. On the left, you can see a panel for managing multiple tasks at once. The main area shows the active task, in this case, ordering a pizza. You see the agent's step-by-step plan and its thought process in text, while on the right, there's a live browser view. Now, let's look under the hood at the system architecture that makes all of this possible. This diagram shows how the Magentic-UI is structured on the user's machine. The core is the Magentic-UI team, that group of agents we just mentioned. What's really key for safety is the use of Docker containers. Think of these as secure, isolated digital sandboxes. The agents can only execute code, browse the web, or access files inside these containers, which prevents them from affecting the user's main system. This sandboxing is a crucial mitigation for security risks. So with that secure architecture in place, this next table details the core logic that actually runs the show. It's an algorithm, basically the step-by-step recipe for the main orchestrator agent. At each step of a task, the orchestrator assesses its progress. What's really cool is that it can decide a replan is needed, and it will loop back to the user for more input. This is where that co-planning and co-tasking we talked about actually happens. If everything's on track, it just tells the right specialized agent what to do next. Moving to the results, this table gives us a clear picture of how Magentic-UI performs on its own, without any human help. It's being tested on several standard benchmarks, which are just challenging sets of tasks designed to measure an agent's capabilities. We can see its performance on benchmarks like GIA, Web Voyager, and Web Games. The results show that while it doesn't beat the top score on every test, it's very competitive, especially on web-based tasks. For instance, it gets over 82% on Web Voyager, which really validates that its underlying agent design is solid. So building on that autonomous performance, this next chart really drives home the core argument, the value of having a human in the loop. The authors test this by adding a simulated user, which is another LLM that acts like a helpful person. When the agent is given guidance from a simulated user with side information, which is essentially a human-written plan for the task, the results are dramatic. The accuracy jumps from around 30% to over 51%. This huge improvement shows that even lightweight human feedback can significantly boost performance, bridging a large part of the gap to human-level accuracy. And that finding really crystallizes the main point. The big takeaway is that human-in-the-loop interaction, where people actively collaborate with AI, isn't just a fallback. Instead, it's a core principle for making these agents both safer and much more effective. Magentic-UI gives researchers a powerful open-source tool to explore exactly how to build that collaboration. That's it for this episode of the AI